to determine if a table of values represents a linear function, I'm going to look for a pattern in the y's. Notice that all these tables they've given us, all my x's are just one apart. That's important to note. If they weren't one apart, it'd be a little more complicated, but we could do it. But they're making it pretty easy for us. So let's look for any patterns we see in the y values. I'm noticing that I subtract 3 to go from 13 to 10. And then I subtract 3 again, and well, if I keep looking, it turns out I'm always subtracting 3. If you notice something like that, where there's a common difference or a common sum that you're adding, there's your evidence that yes, in fact, you have a linear function. We have a constant rate of change. The rate of change this time is always -3. That's what makes a line, having a constant rate of change. So, well, as far as my explanation goes, there I go. I have that constant rate of change. If it is linear, they want us to determine what that function is. Well, again, they've made these very easy for us. I'm going to write this in slope-intercept form. My rate of change is my slope. So my slope this time is -3x. And then I also need a y-intercept. Well, if you look at your table, they've really given me a y-intercept. Remember, these represent points, and so this point right here, 0, 7, is my y-intercept. That's where this graph begins from. So the equation of this should be y equals, or f of x equals, I guess, if I'm writing a function, f of x equals -3x plus 7. Okay? If I take a look at this next table, again, I want to look for a pattern in the y values. I may not know what I'm subtracting, so I could use a calculator to figure that out. But it turns out that to go from 1/2 to 1/4, I'm subtracting a 4th. And then to go from a 4th to an 8th, I'm subtracting an 8th. And then I'm subtracting a 16th, and I'm subtracting a 32nd. So even though there is a pattern here, it's not linear because I'm not changing at the same rate. There's no constant rate of change. So this table of values does not represent a linear function. It might be something else, but it's definitely not linear. It's not going to be a line. All right, and then one last one, although I think you're getting the hang of this by now. I want to look for some patterns. This time it looks like I'm increasing by 0.7 in this between these y values. Again, I'm increasing by 0.7, and it turns out that, yeah, every single time I'm increasing by 0.7. Well, as we've discussed, that's the telltale sign of a linear function. If there's a constant rate of change, a constant number you're adding or subtracting, that's what makes a line a line. There's a constant slope there. So it is linear because we have that constant rate of change. Let's do a function, so I'll do g of x this time, is going to be in slope-intercept form. Well, that constant rate of change is my slope. So 0.7 times x, plus I needed a y-intercept, and remember they've given me that in the table. They were kind enough to do that for us. 0, 3.7 is where the graph will cross the y-axis. So 0.7 plus 3.7, or 0.7x plus 3.7 will be my equation.